For those who don't know, this is Sidney Sudberg, the CSO, right? CSO and founder of Alkemist Labs, and Sid and I known each other forever, and back in the day, worked with Ike Reich at AMAG to do some of the short courses. So, and yeah, so did the microscopy.
We started in the FDA.
Microscopy class.
Microscopy, and then it went to TLC. No, it wasn't. It was microscopy. No, it was TLC first.
TLC, then microscopy.
Yeah, right.
Right. Yeah.
Yeah.
So
that's where we started.
Yeah, and you know, been in this industry a long time, so be some good information here from Sidney, and thank you again for hosting us, and thank you for participating, doing a talk.
Thank you for inviting me, and I really do appreciate everybody being here. I hope you're comfortable, and if not, find somebody to complain to. So I want to keep this as open as possible, and also want to think in terms of, we've all been diving into the weeds the whole morning, getting into the details and picking apart and really evaluating them very, very carefully and nicely in many different ways to apply HPTLC. We're going to zoom out now. Okay, so we're going to exercise a different area of your brain. And while measurement, quantitative, qualitative, they all have uncertainty. So, it's in our lives every day, everywhere. But as a scientist, really, it says here, being a scientist requires having faith in uncertainty, finding pleasure in mystery, learning to cultivate doubt. There is no surer way to screw up an experiment than to be certain of its outcome. So get real. Every measurement is different. That's why we take the mean and we get an average. So in your qualitative analysis of botanicals, you're doing exactly that. How long have, raise your hand when I hit a certain year. How long have you been doing this for a year or less? TLC, it's okay. You get the most attention, so you win. If for your benefit, because this is all new to you, this is prime time to learn how to utilize what you're looking at for future development. So it's a learning process. 5 years, 2 years, 3, 4, 5, 10, 20. That are not part of you. Okay. So this is really, a major portion of what I'm going to be talking about. For all of you who don't understand French, probability theory is nothing but common sense. So when you look at a chromatogram and you're comparing a reference material to a test sample, you're going to have to make some decision. Okay, and even if you have machine learning and algorithms to do that, it's just another data point. It's another measurement. It's not the only possible answer. So that's where you cultivate doubt. The idea from my standpoint for all of you is to think in terms of the quality and the quantity of the data you're collecting. Your images, what does it consist of? Reference materials. How many reference materials does anybody use on their plate? Or do they? I'm assuming you do, but maybe there's other ways. 1, 2, 3, 5, anybody?
Yeah, it depends.
Yeah.
Well, yeah, of course. It always depends. But if you had a choice, do you only think in terms of one sample, one representative sample? Because if you're only thinking in terms of one representative sample, you have to expand your thinking, because when you look at different reference samples, even voucher specimens, phytochemically, the phytochemical constituent profiles vary. Okay? They're going to be variable. But then what do you do with that information when you're comparing to a test sample? Or you compare to a similar related species? So I'm going to show you some examples that hopefully will be meaningful. Okay, you don't have to read all that. But John Tukey, a very famous statistician, developed his career and came up with this expression. See, not my fancy pointer. So this expression here, far better an approximate answer to the right question, which is often vague, than an exact answer to the wrong question, which can always be made more precise. So in terms of TLC, you are making an approximation when you look at these year samples, even down to the voucher specimen it is. Does anybody use, or you all know what a voucher specimen is, et cetera? Okay. So you get these voucher specimens and you examine them, and somebody else examined them to make the identification. Are we certain that they did it correctly? Because apparently in herbariums, which is also true of DNA analysis and where they get the data that they're using, are from, I won't even quote a percentage, but a percentage of what they're using in their database is not necessarily correct. So you have to factor in variability. Okay, so again, the quality and quantity of the evidence of the data is going to be important. And also, I really would like to encourage, my goal would be that you, if you have a question, or if you don't believe what I'm saying, or if you want to give your own opinion, I really would welcome that. Because it would be better for me to be able to interact with you, to know what you're either not interested in, and there may only be two of you who are interested in anything I'm saying. But if that's it, I'm happy with that. So if you have questions, really just throw it out, or anything. So has anybody heard of Bayes' theorem? So Bayes' theorem is actually a way of thinking, and it's like learning from experience. That's what you do with TLC. I don't know if you remember, I do. The first plates or the first test samples that I had to look at, and it was not a common botanical. And it's like, oh my God, I had no idea how this is supposed to look like that. And how much confidence I had in anything I was looking at, and what was my decision-making process. How did I eventually get better at that? I assume you're all beyond that. You feel very comfortable, or do you feel very comfortable making a classification for botanical identity? Do you? Yeah. Okay. You base it on like a single reference material, or have you had like extracts that don't quite look like they're supposed to, and you're not sure whether it's the right or the wrong, or a pass or a fail? I mean, does it come up? Imagine.
Yes.
Okay, so let's move on. I mean, that's true of all of us. I mean, that should be true of all of us, I think. I don't know about you, but that was with me. And, looking at everything first as carefully as possible, band by band. A common statement I use, and I tell people how to, when they evaluate, because we see a high volume of samples, and either you have it memorized because you've seen it however many times. If you see missing bands between a reference material and an extract, let's say a powdered extract, and especially when it comes to water extracts, they're like even less data rich usually.
That's a nice way of putting it. Consider your products less data rich.
Probably. Okay. So when you look at these, I mean, you have to engage other parts of your brain to put the pieces together, which requires prior information. So the more you know about phytochemistry, the more you know about the botanical that you're actually testing. I mean, if you all don't have the plant drug analysis by, what is it? Wagner, yeah, Bauer or somebody else. So do you all have that? I mean, it should be like, well, for me, that was my Bible.
Yeah.
Okay, I mean, I can show you the original copy, and it's got like these, little sticky tabs, like, multicolored all over the place, and writing, etc. If you're not looking at those things, you're missing half of what you need to see. So I heard Jim earlier mention something about like the specifications, and what I think I would recommend is knowing what the specification is as designated by whoever you're testing for, and even if for yourself. If your specification is to the genus, you don't need to be as specific. And that word is important: specificity, sensitivity. You need to know how accurate you're being, and then how much you can distinguish between lane 1 and lane 2. So it's the established specifications. Okay, so it's up to each. I don't know. Are we from like where are you from? Wisconsin. What company? Orthomolecular. Okay, so you're a manufacturer. They're mostly manufacturers here. Is that what we're dealing with? Okay. And you're testing, you're in quality control, obviously, and you're testing incoming material, or you're verifying some of that? Both. Okay. So, and as a result of that, you have to know what your specification is, and then you can modify your evaluation to that spec, as long as it matches what's on the label. So some basic definitions: sensitivity, specificity. Wouldn't worry too much about positive and negative predictive value, but sensitivity is important because after time, what you're doing is validation over time, and you're getting data, and you're narrowing, you're creating your bell curve of how much confidence you have in what you're doing and how you do it. And being aware of what sensitivity is, are these terms familiar to everybody? So then there's identification certainty. That's a parameter that comes up with Bayes' theorem, and it quantifies uncertainty. I'm not going to go into that, but I want you to be aware of that. So ginkgo was brought up earlier. What we've been dealing with, as Jim has as well, is over the years, the adulteration concept has evolved in many different ways, and it continues to evolve. I guess the latest one I'm seeing, I think you mentioned, is the hydrolysis. That I don't know if, but that's what you've seen from test samples, right? So we discovered that quite a while ago, and you have good data out there. Ginkgo is a one you can practically do blind, but in terms of what we will see, not infrequently, is this little cluster here, which at first, because when you start looking at all these reference materials, it's like, oh, that's close, that's close. But something about that drew our attention to it, and then we had to go and develop a method. At first, it was Sephora, but then it became more obvious that there was an issue more with hydrolysis, and it just replicated those compounds. So again, if you're not looking for these things, you're not going to see them. So in this case, everybody familiar with Vitis and Arachis and the adulteration between Arachis and Vitis? Okay. So grape seed extract is not infrequently adulterated with peanut skin, Arachis, with GR. And in this method, what we're looking at is this band. This is Arachis, and it's this band in particular that looks like a clear slam dunk kind of decision. A while back, before we actually started doing this, we did a validation for a specific company that felt that they were being cheated by those companies who were doing this. They wanted us to try to help them prove that this was being done by other manufacturers who were charging a whole lot less. So, we did the validation. This is the method we came up with, and it seemed valid at the time. But then I think what we started to observe were some contradictions, and I'm not sure that it's really readily apparent here. But this band, I mean, it might be slightly above the RF, but I don't know if I have another image that reflects more. There's a different sample, same company, but the color actually started to, and it's when you see this more often and frequently that you start to recognize the pattern. And then you make a decision, investigate further. So we developed a different method that actually identified these basically four orange bands from the Arrakis. And the test samples that we were looking at that we previously failed. But then we talked with the company, which helps us evaluate who we're dealing with and what they're dealing with. And we felt very confident, and this is part of the ability to make or to reduce uncertainty. Because they came across, number one, as a good company. They knew what they were talking about. I trust no one, and I assume nothing. Okay, I'm from New York. I will not ever violate that rule. So you have to earn the trust. And if you don't know somebody and what they're telling you, it's all words. But this company had a good reputation, and I believe them when they said, my material is unquestionably what it is because of this, and whatever that was. Okay, that makes sense. And at the moment, though, I couldn't tell them because as a routine, we would run both of these methods together. Okay, for every Vitis extract, that's grapeseed extract. So we didn't do that. Somehow somebody didn't do what they were supposed to do. And when we had the phone call with the client, I told them right up front, I said, while I am confident in the result as we concluded, I still have to run this method. And we did. And this is the result. And it is not Arrakis that band represents from the data that we're looking at. How certain, how uncertain. I mean, we can do more work. We can, increase the confidence in what we're trying to decide. But these four bands, predictably, whenever we see Arrakis, has some remnant of it. Now, if it's below the limit of detection, I mean, we can talk about all of that. But for all practical purposes, their sample did not fail. And that was the final conclusion. So, okay, so I'm going to run out of time, and I'm going to fast forward, maybe briefly describe, like, how do you know whatever method you're using for whatever botanical is as good as you think it is? It's called validation, right? But how do you validate a qualitative method? Well, this is a method that's been developed. If you're familiar with AOAC and Appendix K and Part 2 and 3, it goes into the details of one application of the statistical model. The statistical model is the foundation for that study and for validation of qualitative methods, specifically for botanical identification. So we did a study where we did TLC, microscopy, and genomic analysis, where we took 15 samples of Mentha piperita, Mentha spicata. We duplicated them, so we have now 30 samples of each, which was required for the statistical evaluation. And now we have 30, and we put them together. Now we have 60 randomly organized, tested by TLC, microscopy, and DNA to see if they can get positive results for the actual identity of those materials. I mean, look, it makes sense. If you're going to be able to say that your method works, you should get all these different samples and be able to distinguish, especially, okay, does everyone know this method? You know which one is peppermint, which one is spearmint by looking at it, or if you don't, I mean, the ones with the big blood red blob, the Areocitrum is that one. The others are spearmint. Now, there are some other species, but this was, I mean, we've done this now 2 or 3 times, so our confidence intervals are getting narrower as we do it each time. So we know this method is capable of actually distinguishing between peppermint and spearmint. What's interesting about that is that DNA, the first time it ran, did not. Microscopy has a terrible, it requires a lot of special talent to be able to distinguish that. So basically, without getting into too much detail here, numerically, PLC and DNA with the most recent iteration of the experiment that we did passed. And, you know, there's just a lot of stuff that you need to know before you just automatically assume you're right. Always leave element of, I mean, you want to be able to justify every decision you're making with whatever data you have. Think of it in terms of the quality of the data and the quantity of the data. So if you need to run 2 methods or 3 methods for any given analysis, run them. I mean, maybe somebody cares, but I personally, that's wrong not to do that. And statistical models are just a model. They're they're the map, they're not the territory. So you have to understand that all models are wrong. And this is George Box, who I'm sure all of you know, but he was a statistician for decades of experience, and that's his decision, his summation. And then, of course, Robert Labud, somebody that I actually, he was a mentor for everything statistics and gave me the ability to think in terms of data, no matter what the data is, can be evaluated. And if you just think of it as logic, you can make those decisions. You can back it up and support it with quantitative and measurement, but you need to also think no model is perfect, but it must work well enough to give useful estimates. That's the bottom line. So if you've never done anything wrong,
Thank you, Sidney.
I don't know if we have time for questions now, but if we don't, I mean, I'll be around today, tomorrow, so you don't have to actually ask questions now.
Yeah, there's a lot of gray when you're doing samples like Alkemist or Florida does, because we were getting them from all these different companies. And sometimes, like a contract manufacturer, their client just says, well, I just need this botanical there. And they'll be pulling in a variety of botanicals that the buyers are getting, and they're all over the map. So there are times when you're looking at extracts where you're like, I don't know, you know, and so we'll do secondary, tertiary analysis. And I want you to take to heart what Sidney said. If you need to run a second method or more to really get confidence in your data, it's worth doing. I mean,
you learn something different with every method that you change. You see things in
Yeah,
one
exactly.
method that you wouldn't see in the other.
Especially if you start associating it with what fraction you're looking at. I mean, you can look at the essential oils, or you can look at the flavonoids, or you can look at the saponins, and you should see consistency unless the extract is targeting a specific fraction. But for botanical to botanical, you really need to consider that. I just want to point out, I mean, if you don't have to be a statistician or even love numbers, but these 2 books are non-numeric. Well, I think I haven't read this one yet, but I think it's the same. This guy writes phenomenally. So the art of uncertainty and the art, and both by the art of uncertainty and the art of statistics. I would start with the art of some uncertainty. It is phenomenal. I mean, even to question the speed of light. Come on. Did you know that Avogadro's number changed after 1941? For all those years, Avogadro had this number, and it changed because they had more accurate, thorough measurements. Same thing with the Millikan and well, anyway, charge on an electron. So but that's just, you know, the weeds. This book is phenomenal. And
that's cool.
David Spiegel, thank you. Have a good lunch.
Thanks again, Sidney.
Thank you.